All right. So, welcome everybody uh, to the second insurance law workshop of the semester. Our guest, as you can see on the screen, both his picture and his title and topic, so it's not much point in my reading them out loud for you. But Yizhou is here from the University of Toronto. He is an economist who's done a lot of work in insurance economics and has thought very, very carefully about how you do empirical work in situations of difficult information and asymmetric information and all kinds of stuff. And so we're delighted to have him here talking about moral hazard. Uh, the floor is yours. Let me know when you want to stop. And if people have questions, you can either chat them to me or you can raise your hand and I will try to find you on the screen. All right. Thank you again for coming and for a great paper.
Thank you so much for the invitation. I have a background in economics, but as part of my dissertation, I started doing work related to auto insurance and in particular, like risky driving, as you will see today, related to, in particular, the application of telematics data. So today, I'm going to be talking about some work that I've done while doing some accident prevention effort at a ride-sharing company. The motivation is driven by just how damaging risky driving and traffic accidents are. In 2023, there are 1.2 million deaths globally related to traffic accidents. And in the US alone, the direct financial impact is about 340 billion or 1.7 trillion if you account for quality adjusted loss of year life, which is a very significant share compared to the GDP. And 94% of US fatalities involve risky driving, with fatality rate rising as opposed to lowering during COVID, for example. So there are a lot that we still don't quite understand about risky driving, especially when it comes to the field. When it comes to the economics of risky driving, one thing that's very salient is the moral hazard effect, which says that, oh, insuring people against accident losses may have this perverse incentive that encourages them to do more risky driving, or may cause them to lead them to relax in their effort to conduct safe driving behaviors, which has played a big role in the design of tort systems and insurance and liability, especially liability insurance mandates. I'll talk more about this towards the end. But empirical work, on the other hand, has only focused on insurance utilization using claims data and produced quite a lot of mixed evidence on whether there is or is not moral hazard in terms of risky driving. The reason why this is the case is partially because it's mostly because of the lack of data, right? For example, like claims are like people don't often observe risky driving, so the only thing we can use are insurance claims data. But these data are often way too sparse and underreported in some sense. Like I'm also referring to police reports here. In order for them to be a to make inference on behavior. And in many settings, strong assumptions are needed in order to separate moral hazard effect from adverse selection. So the central research question of this project is basically, is it possible for us to observe risky driving behavior in the field with this advance in data and AI? And to what degree does this risky driving behavior respond to incentive and therefore lead to these kind of moral hazard effect in risky driving? And just to preview the finding a little bit, if not, if it doesn't respond to incentive, can we think about why that is the case? Okay. Feel free to interrupt me if there's any clarification questions. I aim to sort of have this talk being about 30 to 35 minutes, so we can have a more thorough Q&A afterwards. The roadmap that I'm going to follow today is that I'm firstly going to tell you about the setting and the data. I collaborated with this ride-sharing company, which basically self-insures against accidents incurred by the drivers on the platform. And specifically, we're going to use smartphone sensor data to infer handheld phone use behavior, which I'm gonna abbreviate to HPU from now on. And second, I'm going to show you a series of observational evidence that uh, tells you that HPU is risky. It does lead to accidents. However, it is insensitive to changes in incentives. And I'll be more precise about what I mean by incentives. And therefore, we are kind of looking at a lot of observational evidence of a lack of moral hazard in some sense. So the third section, in an effort to investigate why that is the case, we're going to conduct a nudging experiment that point to the importance of salience issues.
Can I just quickly ask about the insurance? So you're not covered if you're
Yeah,
driving. If you're driving, you're not covered when you're using your car to go to the grocery store or to pick up your kids from school or something like that. It's not that all of your
yeah,
behavior, and you're not monitored then either. Do
yeah.
we know, do we know anything
Mhm.
about how you drive when you're not driving for Lyft, Uber, whatever the anonymous company is?
We don't. We don't. I specifically have many slides on the insurance. Let me introduce that more sort of precisely when I get
Great.
in the
Sorry.
two slides.
Yep.
Yeah. Okay. Let me get into the first section. So the baseline data we have are standard trip level data associated with these risk ride sharing companies. So the average ride is 4.4 miles. The average trip is 4.4 miles and 16.8 minutes. We have very detailed trip level timestamps, geohash, and trip types, so that in the regressions that I'm going to run, I will be able to control for hour of week, week of year fixed effect. I can control for trip start and end geohash 5 fixed effect. You can think about geohash 5 as these five, like 4 to 5 kilometer squares on the map. So I kind of can control for where does this trip start and end I can control for that fixed effect. I also see the number of passengers and the passenger ratings. 26% of trip segments are zero passenger because many trips are the drivers actually en route to pick up the passengers. So in those trips, they are still technically working on the platform, but there's no passenger. Okay. And lastly, 27% of trip has some sort of rain, precipitation. We have very detailed data about precipitation in particular. So we can match that to our data set. We also observe the demand, supply, and traffic proxies for those geohash and at that time. So we have the request and write request and driver densities of the geohash, and we also can control for the fare that is given to the driver at those regions, both per mile and per minute. Besides trip level data, we also have driver and vehicle characteristics. So we can control for age, gender, driving experience. We know their acquisition channel. We know vehicle age and spec. We also have their past accident record, ratings, and passenger reports, which I will get to. So in terms of risk-related outcomes, we do see whether they get into an accident, whether what their ratings are from the passenger, and also passengers can report unsafe behavior as opposed to unsafe behavior in their kind of in their comments, and also they can potentially even be escalated in some cases. Okay. To answer Peter's question about ride-sharing insurance, there are three types of segments here. Firstly, when the application is off, when the person is just driving for without turning on the app, it is fully covered by their own personal auto insurance. As soon as they go online to the app, their personal auto insurance still is the primary payer of any liabilities. But if it's in the event that it is not enough, the company offers a $50,000 liability coverage per person. It is really when the starting from the time that a driver accepts a trip all the way to when he or she picks up the passenger and then drop that passenger off, this period is covered by the company's own policy, which includes $1 million of liability limits for third-party liabilities and up to $1 million limit for uninsured or underinsured motor or slash mat pay. I'll be more precise about what this is in just a little bit. And also a $1,000 deductible for own car damage. And specifically, personal auto insurance does not cover this period.
Yep.
Okay. And I want to specifically mention that this med pay coverage covers driver's own injury that is not covered by others' liability. This is regardless of fault. Typically, in no-fault state, this is very important. But in some at-fault states, there's also some relevance of this coverage as well. It'll come in one of the reduced form exercise that we're going to do. Also, there's no coverage choice. This is basically standard policy for every driver. And the company self-insures, but passes some insurance costs onto drivers via a commission. So basically, their commission, part of their commission would be deducted in order to pay for insurance. Okay, the last important background that I want to cover is how we get to this behavioral observation. Okay, so because they have to use their smartphone for navigation and for working on this platform, we technically have a wealth of smartphone sensor data. So what we did, similar to some of the prior applications of telematics, is to turn those sensor data into actual identification of risky behaviors. And what we're going to focus on is handheld phone use. Handheld phone use is basically, you can think about it as text and drive, handheld calls or phone navigation while driving. It's illegal in 19 states. Text and drive in particular is illegal in all states. It is responsible for 8%, 23%, and 30% of fatalities in US, Canada, and Shanghai based on some official statistics. So how we get to here is quite complex, but I'm gonna, for the interest of time, I'm gonna be brief here, but I'm very happy to talk about this in the Q&A. But I want you to take away 3 points here, how we translate sensor data to HPU behavior. Firstly, HPU behavior is very easily identifiable because it's associated with very distinct large short consecutive spikes in gyro sensor. So the phone is like really spinning a lot while the orientation of the phone being aligned or vertical to car movement and the phone moving at non-trivial speed. So this is actually very intuitive, even though like we arrived here with a very complex and black box machine learning algorithm, the result is actually very intuitive to us. And second, this model is trained and validated on ground truth data. So we spent money to purchase these human labeled data sets of specifying the exact seconds where a driver is or is not using their phone while driving. And in our validation, we have been very conservative in identifying HPU so that we achieve almost 100% precision and about 70% recall. What this means is that false positive is almost zero. If we say that someone is holding their phone, we're very certain that that person is holding their phone. The trade-off is that there will be some false negatives. So sometimes when a driver is holding their phones, maybe we won't be able to identify it in some complex cases. This is because in order for us to feel confident about intervention related to HPU, we need to be very certain that they're actually engaging in such behaviors. But conditional on this precision rate, this recall rate is also industry leading. So it's a very good algorithm.
If I have my phone on
Mhm.
a mount and I'm texting without actually holding it, but it's just like mounted on the dashboard and I'm typing in numbers, does that trigger your
It
uh,
is not. It is specifically not handheld phone use.
okay.
Yeah.
So, and is that, I mean, I don't know whether that's a thing that people actually even do if they have, like, I don't do any of that, but is that,
Oh,
do you need to
they
worry
definitely
about that?
do.
So
Yeah.
texting while not holding it in your hand, but leaving it in a mount.
Yeah, there are, let me be very clear that there are many other unsafe behaviors that we're not capturing.
Yes.
We're specifically focusing on this because we're very certain about the precision of it, I think,
Okay.
most importantly, and the fact that it is specifically illegal in many cases. Um, So some key statistic that you should take away from um, before we get into the analysis is that the mean HPU frequency is just under 1%, which is about 9 meters per kilometer. At the average speed, this translates into 10 seconds per trip, or one handheld phone use mile driven per 116 miles driven. Okay. Um, a very important feature of this data is that we see that top 5% of drivers make up 76% of total HPO miles, and the top 10% of drivers make up 90% of total miles. So a lot of the variation in HPU that you see across trips is explained by across driver persistent differences, as opposed to like more of it is explained by across driver persistent difference as opposed to within driver across trip differences. Okay, so some drivers are just does more HPU than others. Okay, so that's the data and the setting. Let me then present to you our observational a series of observational results, um, which we're going to first show you that HPU is risky. It leads to accidents. And then we're going to show you that variation in the riskiness of it across different settings is not going to change HPU frequency for a driver very much. Okay. So the first half of that is HPU causes accident. Um, I'm going to first show you a very direct, descriptive fact here, which is that in rise where we know there's an accident due to reports, we can actually very often precisely identify when that accident happened. Because typically it is associated with a very sharp decline in speed, followed by a prolonged period of stopping. So in those rise, we are actually able to understand very precisely whether some risky behaviors happened before the accident. So here I am plotting on the x-axis an accident timeline where 0 is the beginning of that decline of speed that led to the accident. And I'm plotting on a 30-second interval the HPU frequency, okay, leading up to the accident. You can see that in these rise, the baseline HPU frequency before accident is already 3 times as high as the normal HPU frequency. But this number jumps to 11 times in the 30-second window before that sudden stop that led to the accident. So it is a very kind of from a temporal perspective, you can see that there is a direct sort of a relationship between handheld phone use and accidents. But we can also quantify that a little bit in a linear probability model where we regress the occurrence of accident on handheld phone use frequency, controlling for the observables and fixed effect that I mentioned in the beginning. Um, and in particular, as you can see in the last slide, there are some handheld phone use even after the accident, which could be because they needed to use their phone to report the accident or something like that. So in order to address these kind of reverse causality issue, we're going to remove all of the HPU records after accidents. we did robustness with and without doing this, and the result is not heavily influenced by this. So the result, basically this lambda b coefficient here, uh, basically translate into a very simple one-to-one relationship if you convert the unit to second per trip. So increasing HPU frequency by 1 second per trip will lead to an 1% increase in accident rate. So that is basically our main result, demonstrating that based on our own measure, we can still see very precise evidence on the riskiness of this HPU behavior.
And that accident
Mm.
rate is per trip or per mile or or it doesn't even matter? Like what's, yeah, the 1% of
We have
what?
tried different, yeah, we have tried different measures. Here, I'm showing you just whether this I is a consumer, I is a driver, T is a trip. So it's just a trip level indicator. And then on the right-hand side is going to be HPU frequency over this ride. Yeah. But we have done different specifications where you just divide it by miles or divide it by time, for example. Yeah.
So that seems
So,
really high. Doesn't that seem incredibly high?
but notice that the average is 10 seconds per trip. So a 1 second increase is actually a 10% increase. Okay. Yeah. So the actual elasticity is something more like 0.1. Okay. Okay. So now that we've established a kind of positive relationship that HPU actually leads to more accident, we need to think about, okay, are drivers being rational about this behavior? To what extent are they, for example, doing less HPU in environment where the riskiness of HPU is higher or where they are less covered by insurance? Okay. So firstly, to estimate whether this behavior respond to incentives, we need some variation in this lambda b term. So maybe this behavior is more risky in rise with precipitation. Like when the driving condition becomes more complex, maybe you should be even more careful not to use your phone. So in our specification, we can interact this B term HPU frequency with a bunch of observables, with precipitation in particular, and we find that HPU is 38% riskier in trips with precipitation. The standard error is pretty big here, but I should know that it is very similar to another estimate from a kind of study in 2019. Okay, so now that we know that rainy rides are associated with higher riskiness of HPU, right? Does that actually lead to lower HPU behavior? So we can regress that behavior on whether there's rain, controlling for the same observables, right? But the issue with this is that we worry a little bit about what's called selection on trip level unobservables. So maybe the passengers are different when you have a rain ride. Maybe the drivers are different when you are that would unobservably influence their need to use the phone. So in order to address that, we're going to control for the precipitation level at the trip start, but also look at how within trip precipitation change would impact the behavior. So for example, conditional on there is no rain, or conditional on there is like a little bit of rain in the beginning of the trip.
Mhm.
What we're comparing basically a similar trip where the end of the trip has a lot of rain and where the end of the trip has no rain at all. Okay, so based on this estimate, we find that rainy weather on average reduces HPU by only 1%. Okay, remember it is 38% riskier. This means that if we are to estimate a elasticity term on moral hazard, which is like, does the increase in risk exposure lead to a reduction in behavior, if we term this as an elasticity, the elasticity would be like negative 0.03, which is quite low. Okay, I'm just going to know that even if we use delta one, which is the kind of cross trip difference, we're also going to get a similar estimate. So they don't seem to be responding a lot to the riskiness here. We also, the second evidence that we're going to present is directly related to moral hazard in the insurance sense. So remember that I told you that there's the second coverage for drivers, especially this MetPay coverage, which is, oh, suppose you hit someone or you are hit by someone and you yourself is injured, right? Then this insurance will cover that injury, medical payments. That is not covered by the other person's liability. So during our research window, this coverage limit actually went down from $1 million, anywhere between, actually, this is up to $1 million. This is between 250,000 to $1 million. So it went down, but it went down from that high number back to the state mandatory minimum, which is anywhere between 50,000 and not at all. So the expected insurance saving actually varied widely across states. In many states, this had zero impact based on sort of past claims data. So we estimated like almost zero insurance saving from this change. But in some states, especially at no-fault states, this is very significant. So based on our estimate, in 3 states, the expected insurance saving is more than $1 per ride. So it is quite significant of a reduction in insurance coverage in some states. So the drivers received a reminder email about this a day before it took effect as well as the kind of initial announcement. So let's think about whether this plausibly exogenous change in insurance coverage actually led to any difference in the progression of HPU. So here I am plotting on the x-axis calendar days relative to the insurance reduction, when the insurance reduction took effect, with 0 being that first day where the insurance reduction took effect. Okay, the y-axis is the HPU, is our estimate on the HPU state calendar day fixed effect. You can think about it as the residual HPU frequency after I have controlled for all of the observables that I mentioned before. Okay, and the y-axis, the unit here is a standard deviation of HPU. Each line represents the progression of residual HPU of a particular state, and the yellow lines are the affected states post the insurance reduction. Right. Okay, so with this series, we can do a synthetic control analysis in which the black line here represents the average among the treated state, whereas the blue line is a synthetic control that we constructed that closely map the black line, right? That can be used as plausibly a counterfactual of the black line. So in particular, we used a new package that includes cross-validation in the pre-period so that we know that the blue line, we're not like overfitting in the pre-period here. So in the post-period, you can see that the 2 lines still very much overlap with each other, which indicates that probably the treatment effect is very low. And we can be even more precise here by summarizing that with an average treatment effect number. So here, the y-axis remain the same. I'm going to first think about what do we expect to see if there is a large moral hazard effect, right? You would see something like these gray dots, right? So you should see that when they reduce insurance coverage, the HPU frequency is going to reduce. And in particular, when I dissect or when I trisect the affected states into low impact, medium impact, and high impact states, I should see this kind of negative relationship, right? Remember, some states are more affected by this insurance reduction than other states, right? However, this is what we saw. Like we see very precise zero average treatment effects across the board. So essentially, I think taken together, our observational study basically said that, oh, we really don't see people are rationally adjusting their risky behavior in the field to significant changes of the riskiness of this behavior. So if they are not rational, if they don't seem to be super rational, why is that the case, right? We can think about this as either they are super, they have super high preference for HPU. They just really need to hold their phone. That's one explanation. But they could be, subject to some sort of bounded rationality issues, right? And in particular, even if you're focused on the like bounded rationality, there are different interpretations here because car accidents are rare, but like ever-present risks on the road, right? So probability weighting or prospect theory would tell you that these kind of low probability event will be overweighted, and with actually quite a lot of support in the insurance economics literature, which would kind of contradict our evidence. But salience effect would say that drivers may not actually perceive risk changes on a continual basis and adjusting their behaviors accordingly, especially as they're multitasking on other tasks that's unrelated to safety, like where are you going, when are you going to arrive, right? So this would kind of explain the evidence that we see, but to further prove that, we are going to do some nudging experiment to try to see maybe it is possible to change their behavior. They're just having some salience issue, right? So that's what motivated our RCT. So the treatment here is a very simple one-time text message where we basically said that, oh, hi from the company. Our app shows that you may be holding your phone while driving. Passenger reports of unsafe driving, like handheld phone use, can lead to suspension. What we're doing is raising the salience of drivers' own behavior of HPU, right? And also we're raising the salience of an incentive, which is HPU suspension risk. And the execution of this experiment is that, firstly, we targeted the 14,000 drivers that are at the top 5 percentile of HPU, which, remember, is responsible for the vast majority of HPU miles. We also narrowed down to drivers that drove 20 plus hours per week in the past quarter on average, so that we're pretty sure that these people are actually, drivers, as opposed to very kind of occasional participants. The treatment assignment is that we send the text message to 50% of targeted drivers that started a shift during 3 to 3:30 Eastern time. And that we can detect that their GPS speed is 0, so that we're not sending a text while they're driving. Okay, this treatment is triggered at lock-on. So this is one note about the suspension incentive is that it is only relevant when passengers are present because it works through passenger report, and it applies to all unsafe behaviors. Speeding and HPU are by far the most frequent mentions. Okay, so this is the experimental result. On the x-axis, I'm plotting days since the experiment. So the first dot here at 0 is the 24-hour window after we sent the text message. You can see a very strong initial effect of 33%, exactly 33% reduction on the first day. But it kind of revert back and stabilized at around 15% after a week. You can see that starting from day 30, we start to get a lot noisier of an estimate. That's because we start to run into COVID lockdown. This happened in the beginning of February in 2020. So accompanying this is we did not detect any change in driving hours. And At the same time, sometimes we worry about, oh, did they kind of figure out a way to bypass our algorithm? Maybe they have like another phone or something like that. So it didn't really lead to a actual reduction of risky behavior. We did worry about that, but we did use near misses as a proxy for like accidents, for a very rare accident. And we did see that near misses also actually reduced quite a lot, which give us some indication that it seems like they really are reducing these behaviors that led to safer driving. And lastly, we there's some, remember our pilot experiment. This is our pilot experiment. So it wasn't kind of a 10 experiment arm, like carefully designed intervention. But I still think it can already tell us something about whether it is the salient effect on the behavior itself that's working, or are we just raising the salience of the suspension risk itself? Um, and I'm going to say that is mostly going to be the former because of the following. First, if they are just suddenly very scared about suspension, we should see that there are other risky behavior that's also going to lead to reporting and suspension also reduce, which we do not. And at the same time, we saw a very similar percentage drop in HPU, even in trip segments that had no passengers, which they were definitely not subject to those complaints, and then suspension risks. Right. And lastly, it does seem like they are a little bit like what the heterogeneous treatment effect. It does suggest that it's related to the salience effect of the accident risk, or the HPU as an accident inducing behavior relative to just a suspension inducing action. For example, we see the effect being weaker among drivers with accidents or recent near misses. We also see that the effect is stronger in snow and rain rides. So we're going to conclude that it is we're seeing this huge effect probably because people are increasingly aware of their HPU behavior and the accident risk associated with it. Okay, so let me conclude. In this talk, in this project, we essentially used behavioral data, newly minted behavioral data, to empirically study what's called ex-ante moral hazard, which is moral hazard related to risky driving or kind of some sort of prevention effort before any risk has realized, right? In particular, we point out that smartphones have introduced a lot of possibility to mine sensor data and conduct experiment at scale. Our main result is that there's just very little evidence of moral hazard with respect to HPU in the field. And that's probably driven by salience issues. And the implication, first and foremost, is that the traditional more second best contracts in the kind of moral hazard sense is not constraint optimal. What I mean by that is that just because you give less insurance coverage does not necessarily induce safer driving. And secondly, I think it also underlies a broader change in actual risk management, where managers are starting to realize that, oh, maybe people can change, so that our strategy may broaden from just selectively risk share so that we can manage our risk exposure to actual accident prevention. And lastly, in terms of policies, I think this can contribute to some discussions about the low mandate and underinsurance in the US, because if giving them low coverage is not going to actually have any deterrence effect on accident, maybe we can consider raising our kind of liability mandate or limits to beyond the current level of like 30,000, 25,000, relative to the millions in a lot of other places in the world. Okay, that's all of my talk. Thank you
That's
very
all.
much.
That's all. Thank you very much. Um,
Mhm.
I have a gazillion questions, but I don't want to preempt the queue. So I'm not sure how you raise your hand in Zoom, I'm embarrassed to say. But you can text me or you can raise your hand on the screen. All right, so maybe I'll start just because I can't see anybody else at the moment. So
Mhm.
I didn't see here, I mean, moral hazard is often associated with the inability to monitor. And right, if I knew exactly how your risky behavior was changing with insurance, then as the insurance company, I could just charge you a higher premium for those times when you're doing risky stuff and charge you a lower premium otherwise.
Hmm.
But you have the natural setting where there's a passenger who's monitoring, at least on the trips that have a passenger. What kind of a difference do you find in riskiness between passenger trips and non? Are they more risky when they're not driving a passenger, when it's only themselves, or is it really what's concerning them is like I might get into an accident and I might hurt myself? Uh, can you learn anything from that difference?
Yeah, drivers are substantially less risky when there are passengers. Yeah, so the reduction, for example, like when I said when I said here, the I said like there's a similar percentage treatment effect in the
Hmm.
two types of ride. But if you just look at the level, the
Yeah.
treatment effect in the non-passenger rides are much larger, just because the baseline is also much higher. Yeah. Um,
So if we want
yeah.
safe driving for the regular public, we should just make sure that you always have a passenger with you who's not so closely related to you that they won't report you if you do something bad.
Yeah, yeah. I believe there's also some research about how, when there are children in the
Mm,
car, like people are substantially safer.
mm.
I think it's a similar type of mechanism. Yeah.
And one quick follow-up that maybe it just doesn't seem like your data speak to, but
Hmm.
you know, I don't know about Uber drivers. The taxi cab drivers that I've ridden with just seem like they're just a lot risky. Like they like to speed around all over the place. They want to move on to the next fare. If you were trying to
Hmm.
extend this to a different population, namely the average driver on the road who's not working for a ride-sharing company, how
Hmm.
do you feel about whether this population, it's like a external validity question, does it match? Are you as confident that we would see the same thing if we could somehow monitor everybody as opposed to just the professional drivers?
Yeah. I mean, in my other project with Shoshana,
Yeah.
we're definitely looking at non-commercial drivers. One thing that is true is that there's also more across. We at the time we didn't actually use any actual monitoring data for our analysis there, but we did dig into the monitoring data a little bit in the beginning. We did real like for example, this bigger difference on the driver level. Uh, Compared to within driver variation, that result also holds for non-commercial drivers. So you definitely have a group of drivers that are extremely unsafe, it seems. Um, right. But to your point, sometimes like one of the complexities about driving is that it is very hard to say that people are being super irrational about risky driving because on especially on other dimensions like speeding, because sometimes a lot of people would prefer a little bit of speeding
Mhm.
because they need to get somewhere, really
Yep.
quickly. They're late for a plane or something like that. So that's also why we focus on handheld phone use because it's more clear cut of something that you can avoid. You can like even if you put it on a phone holder, that would be better.
Hmm.
Um, yeah,
Great. So I have Travis and then Seema and Brenda had a comment as well. So in that order, Travis, you're up.
Thanks. So anyway, thanks for a fascinating paper. I'm interested in the exogenous MedPay um, coverage change. So, I mean, it seems
yeah.
like equally plausible explanation for what's going on there is that like the drivers don't understand the meaning of the change. Either like they don't understand
Hmm.
the email, they didn't read the email, or uh,
Hmm.
and I mean that intuitively that seems plausible to me. Like one of those things that you see all the time in like
Hmm.
literature is that
Hmm.
nobody understands their insurance at all. Much less,
Absolutely.
yeah. So like, is there any way to kind of measure that or control for that? I mean,
Hmm.
and like maybe relatedly, if I'd be interested to see like what language you use to like what the language of the email was. Like, how do how
Yeah.
how big did you how big
Yeah.
was like how hard did you shake them to bring this to their attention?
So the actual email was I wasn't allowed to do a screenshot, but I have the of the email. It was basically we're updating our insurance. Please read this new terms and service, which actually, if you click into it, they did highlight the change. Yeah,
Mhm.
but I fully agree with you that not a lot of people understand exactly how they're covered, let alone sort of being very responsive to the change. But I do think that is the result, is part of the result itself. If people don't know anything about insurance, how do we expect to for the sort of insurance design, for example, to have a risk deterrence effect. That's just not gonna happen, right? So I think part of the salience issue that I'm referring to is exactly about the salience of this kind of risk exposure, which includes how much they're covered by the insurance. We did make sure that this actually happened by checking the subreddits of the drivers. There are discussions, especially in one of the no-fault states. Immediately, like after this email, there were discussion about this, some discussion, but it also was not like 1,000 people are upvoting it. I remember there were like 200 people that were upvoting a post that said, "Oh, we're no longer covered." Yeah.
Fascinating. Thanks.
Just to push back on that
Yeah.
quickly, I mean, you could imagine that there's a difference between when you sign up for insurance and you have to say, I want the 25, the 50, 25, or the 100, 150 or whatever. Like at that moment, at least you've paid attention, even if you later forget about it. But the other extreme is that your insurance company just changes the policy without you even knowing about it. And of course, that can't possibly have an effect. So I guess, I mean, I think like the fact that you checked their Reddits, that's amazing and fantastic. But I'm still a little concerned that, you're not really measuring the salience that drives actual drivers in the real world, because I think the moment where it could be the most salient is at the moment that you sign up and you do have to opt into one of the coverages that they offer you. Yeah.
I agree. I agree with Dr. D. It is different from a choice. Like when you offer them a choice, maybe they're more salient, right? I do agree with that.
Great.
Yeah.
Seema is next, and then Brenda. Nope, you're muted, Seema.
Thanks for the great presentation. I know a couple of insurances, auto insurances in US are like offering for the personal driving as well, that if you allow them to track, they give you like 5% or 10% discount on your prices. But the caveat over there is that eventually, based on your driving pattern or trends, they will increase your prices accordingly. If you're a safe driver, that's fine. I think Roots Insurance is the one probably which definitely tracks your pattern on that trends, and that how risky they also include the like not only speeding, but they also include within the different aspects as well.
Yeah.
I was just that was just a comment on that one, but I was just curious that when the data that you have analyzed, did you also look at the contract of the individual's contract, company's contract with the drivers? For example, that the contract or like the communication from the company that, okay, if you get like more than one messages that you're speeding and all, then it might impact XYZ for you,
Yeah,
something on those
absolutely.
lines.
Yeah, we specifically this term of this is we like this intervention did not
Yes.
change the suspension risk. We simply kind of reminded them that there's already a policy for it. So at the end of the text message, there is a link of frequently like FAQ page, which is also linked to specifically like a very long terms and service agreement about suspension. The way the suspension actually works is that the second unsafe driving complaints is going to trigger human variation and potential suspension, depending on the severity of it. Yeah.
So, I mean, I'm just curious, sorry, one more point that maybe I mean, after getting one suspension, the drivers become overcautious on that end. So it's like driving under pressure or something. Did
I
you
think
take that into
yeah,
account?
I think overcautious is good.
Overcautious is good, but yeah, I mean, sometimes being under
It could
the
be.
pressure. Yes,
I
because
think,
yeah.
like to your point, I think a better way of saying what you're describing is that, yes, this is kind of, this is how they're driving in the pre-period is like a high level OHPU, and then we're seeing this reduction here. But we can't necessarily be very certain that this post level is just the rational level. It could be like it could be a like a overly cautious level as well. I think that's that doesn't necessarily reflect the optimal level of unsafe driving. To that, I would say that firstly, when I first presented this paper, a lot of people said that the optimal level should be 0, which I don't necessarily agree. But I do think people have different philosophies about that. And secondly, I think the main point of this nudging experiment is not necessarily say that, oh, the post period is definitely rational per se. Rather, it is to say that people's behavior can be changed. It is just not changed by the observational variations in the risk in the previous section. That is sort of it is not like, oh, maybe our data has some issue. Maybe like people are just so innately sort of needing to hold their phones that nothing is going to work to move their behavior. I think this experiment works to dispel that kind of concern, as opposed to necessarily proving that, oh, we're going to arrive at a more rational benchmark afterwards.
Great.
Thank
So
you.
Scott Huber is next. Scott.
Hi. Actually, you're on the perfect slide here. I was wondering about, so this goes out to 50 days, and I said that it starts to run into the COVID lockdown. I was
Yeah.
wondering if you had any chance to look at presumably that was 5 years ago. Did you ever just look at the data points past 50 days to see what happens? I'm just
I would
curious.
love to. Yeah, I would love to. But we can't. We basically, our data agreement only covers to mid that year. We were originally planning to do another sort of subsequent, more detailed intervention where we have salience arm, where an incentive arm, etc. But we didn't even get to do that. Yeah.
Gotcha.
It
Yeah.
is difficult to work with a private company, especially after the person that you work with has left the firm.
Uh-oh.
Gotcha. Thanks.
Does this seem, I
Thank
mean,
you.
salience is such an interesting word, but it seems a little hard for me to believe that 50 days after you get this thing, it,
Hmm.
I mean, just like as a person in the world, I have these habits, and okay, you might be able to shock me into for a while using my phone less, but 50 days, I mean, sort of follows up on Scott's question. 50 days seems like an
Hmm.
awful long time for that to change my behavior, with nothing
Hmm.
happening in the middle. Does that seem like,
Hmm.
shouldn't the salience wear off at that point?
I think yes and no. Firstly, there is a immediate salience effect that
Hmm.
went away pretty quickly. Right, the first day is like crazy reduction, and then it
Yeah.
kind of stabilized at like half that magnitude. Um, but I also think salience can lead you to kind of potentially purchase a phone mount and start using it and forming a
Oh.
different
Mhm.
habit potentially. It is difficult for us to specifically tease out exactly what is salient and what is kind of habit formation, for example. I do think the two things are very much related. um, you have to have a salient spurt in order to cause you to potentially change your habit, for example. Originally, I even titled this paper as moral hazard under inattention, but there's also quite a lot of different connotations about what people think about what different people think about inattention, like rational inattention versus kind of other types of inattention. So I think salience is just a more conservative word that we're using.
Hmm. Okay, great. Brenda, I saw that you had some things, but I don't see you on the list of participants. So are you even here still, Brenda?
I am
Oh,
here.
great.
This is
Fantastic.
Brenda Cood.
Yep.
And just a couple of comments, one to follow up on what you were just talking about, habit
Yeah.
formation, which, you always hear it takes 6 weeks to form a habit. I don't know if somebody made that up. It's based on research. So your 50 days would fall within, if my math is right, would fall within that period of time. I posted two things. One, some people might be interested in a
Oh.
push by Uber to disclose the cost of insurance, how much of your fare was an insurance cost. I think that's only in some states, and there's some
Yeah.
issues about how accurate that really is.
Mm.
But if you'd had longer to do this and other opportunities for interventions, I think it would be interesting to see what a positive nudge might do, like, and we'll buy you a phone mount, or a phone mount on average cost
Yeah. Yeah.
$5 or whatever, so if you haven't
Hmm.
done this, you may not really know. And then I
Yeah.
can't think of the name of this method, but when someone says no, then the follow-up question is, are you sure you really want to increase your risk by continuing to use your phone, a handheld phone? And
Mm,
I think all of those could be interesting in future work that you or someone else might
got
do.
it.
So thank you.
Yeah, yeah. Thank you so much. Yeah, we definitely have heard of the company sending out free phone mod that has company logo on it as well. It was I think I firmly believe that probably has like a very big impact. It's just we didn't really get to measure it.
Right.
We did, like, even in my own experience, I see people use those phone mounts, like drivers
Mhm.
use those phone mounts. Yeah. I'm
Mhm.
very kind of, I became really, you know, uh,
Aware.
picking those things out in my own experience after working on this. Yeah.
Mhm.
So maybe one more from the audience. I have a million. Anybody? So let me ask you, like, your other paper uh, with the consumer data.
Hmm.
Let me just back up. If you,
I have a little bit here.
this
Yeah.
is already so elaborate, and I'm not even trying to hint that you should do more. But like, if you were Uber, what would you want?
Hmm.
How much phone use would you want zero phone use? Uh,
Yeah.
or what do you think they're, because as somebody mentioned, like customers want to go fast and they want to get to their destinations as quickly as possible.
Mm.
Obviously, they
Yeah.
don't want risky, like they don't. That's the speed margin, but the phone use margin, presumably the customers want zero handheld phone use. Is that right?
Yeah.
So
Yeah.
why doesn't Uber
I,
do more? If they're profit maximizing, why don't they do more, even with the inattention and all that? Like, why don't they try to, not Uber in particular, the company?
yeah. So, we actually, me and then another researcher called Thomas Yu, we worked on a structural modeling of this related to this work a little bit. Actually, just in the um, going back to what Sima was talking about, let's assume that the post-experiment data, driving data, represents a rational level of HPU. Okay, that's what the drivers have decided that they really want to do, given that they're aware of the risk. Okay, then we can actually estimate based on the suspension risk and the accident risk what their preference of holding their phone
Mm-hmm.
is.
Mm-hmm.
So that structural model is basically using a power utility function to back out what is underlying that beta term that I showed you earlier,
Okay.
which was like negative 0.03. But that term became larger when you start to account for when you start to account for suspension risk and when you estimate it based on the post period data. So what the result is that we definitely don't see that, because there's still handheld phone use even in the post period. So the result is that the optimal amount of handheld phone use is definitely not zero. But you can reduce that by charging people some money per mile of handheld phone use
Yeah.
up to a certain amount, because there is a baseline level that's very difficult to not like pay them to punish them away.
So
Yeah,
just
based on that estimation.
optimal, you mean the social optimum for Uber, the passenger, and the rider, given that the driver values the use pretty heavily, so they don't want to give that up. But
That's a
Uber
great
could
question.
be
You
pushing them to do
can,
more, couldn't they?
yeah, totally. That optimal is based on kind of what we think about as social welfare, which is
Everybody.
the driver's utility minus the costs. Um, in other words, what if we get rid of you can think about moral hazard as an externality problem,
Mm-hmm.
right? Your bad action has a negative externality on other people. That's why we
Yep.
care about moral hazard a lot. So if we remove the externality, how much money do we need to punish on HPU in order to fully recover the no externality baseline. That's the kind of the structural exercise. Yeah, it requires quite a few assumptions about their understanding of suspension risk. Granted, even we have to be very careful in trying to understand how exactly do we like quantify suspension risk. But I think what that demonstrated is that it is possible to write that kind of first best insurance contracts now. Like if you are to try to just say, okay, right now I'm charging you 18% commission rate, like I'm taking 18% off of your earnings to pay for insurance, but that 18% is going to vary depending on your miles of HPU driven at a fixed rate, for example. Like we can simulate what that contract is going to do to behavior and accident.
Well, it's 5:01, and people can just vanish in this electronic room by just clicking. So I don't need to excuse anybody, but it seems like we've taken an hour of your time, and you've taken an hour and filled it with a fabulous paper and really interesting discussion. Thank you very much.
Thank you.
And come back again. If you do more work in this area, we'd love to have you back.
Of course. And please let me know if you have any suggestions, and especially related to telematics, auto insurance, etc. I'm very passionate about this area.
It's clear.
Yeah.
Thank you again.
Thank you so much.